Welcome to our tutorial. In this video, we're going to have part 2 of general physics, which we started. If you have not watched part 1, just check in the description. I've added a link that is going to take you straight to part 1 of this particular video. So if you are new to Proflan, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. Just give this video a thumbs up, and if you can be able to share and recommend this channel to your friends, it will be much help to me, because I can see that we have quite a number of people who are watching my videos, but the subscription is a bit low. Just subscribe so that you can be able to help me grow the channel. So the next part that we're going to look at now is how to determine the spring constant from a graph, extension and load graphs, extension and force graphs. So in this case, we want to find the spring constant, but from the graph we have the length against the weights that were added in that particular spring for it to stretch. And then now, how do we find the spring constant? Remember, force is equals to spring constant times extension, which we've highlighted there. Then for us to be able to work out this, we are going to identify a point on the graph, and then we can be able to read the force and the length. So this is the length when a force was added. This is the original length when there was no force. When there was no force, the length of the spring was 0.12, but when a given force that is 6.6 newtons was added, the length became 0.40. Then how are we going to work out now the spring constant? We are going to make extension subject of the formula in this case, and then we are going to first find the extension. And remember, extension is obtained from the new length of the spring minus the original length when there is no another load on that. Then since the new length here was 0.40 and the original length when there is no another mass, it was 0.12, then if we subtract that, it gives us 0.28 as this extension. That is the extension. I need to change that to n, to meters. Yeah, so that becomes meters, right? So once we've confirmed that, then we're going to say now a spring constant is force divided by extension, and the force we got it to be 6.6 divided by the extension, which is 0.28. So if you work it out using your calculator, let's just crunch that in the calculator. If you work it out, that is 6.6 divided by 0.28. That translates to 23 point something there. So if we are going to write this, this is going to be 23.6 newton per meter. So that becomes the spring constant. So in the event that you are given a question to do with spring constant, that is exactly what you're going to do. Another area that is very important, an area that you can be tested, is the area of moments. So you need to understand the conditions for equilibrium, and you need to understand how a moment is calculated. Remember, moment is a product of force and perpendicular distance from the pivot. And then also you need to understand the principle of moment, that anti-clockwise moment is equals to clockwise moment. And now this question here, candidates were supposed to state the two conditions needed for an object to be at equilibrium. So if an object is at equilibrium, it means that the clockwise moment is equals to anti-clockwise moment, and also forces in any direction are equal. So in that case, if you are talking about downward forces and upward forces, they are equal, or forces to the left and forces to the right are going to be equal in that case. We have another question here whereby we need to check what happened here. Yeah. So this is the question to do with resultant force. we need to check what really happened and what transpired at that point. What transpired at this point. I think there was a problem with this part. Yeah, so let's just correct it in a short while so that we can be able to see the next question. Let's see, there was a mistake there. So if I just move this, I think there was a problem. I need to correct that. Just give me a second, I correct that.